set frozen set. A set object is an unordered collection of distinct hassable objects. Common usage uses include membership testing, removing duplicate from a sequence, and computing mathematical operations such as intersection, union, difference, and symmetric difference. For other containers, see the built-in dict list tuple classes and the collections module. Like other collections, sets support x in set, length of set, and for x in set being an unordered collection. Set do not record element position or order of insertion. Accordingly, set do not support indexing, slicing, or other sequences like behavior. There are currently two built-in set types, set and frozen set. The set type is mutable. The contents can be changed using methods like add and remove. Since it is mutable, it has no hash value and cannot be used as either a dictionary key or as an element of another set. The frozen set type is immutable and hashable. Its contents cannot be altered after it is created. It can therefore be used as a dictionary key or as an element of another set. Non-empty sets, not frozen sets, can be created by placing a comma separated list of elements within braces. For example, Jack as Jord. In addition to set constructor, the constructor for both classes work the same way. Class set iterable, class frozen set iterable. Return a new set or frozen set object whose elements are taken from iterable. The elements of a set must be hashable to represent sets of sets. The inner sets must be frozen set object. If iterable is not specified, a new empty set is returned. Sets can be created by several means. Use a comma separated list of elements within braces. Jack as Jord. Use a set comprehension C for C in abracadabra if C not in ABC. For C, if C not in ABC. Use the type constructor set foo bar set ABC AB foo. Instances of set and frozen set provide the following operations. Length of S, return the number of elements in sets. Cardinality of S X in S, test X for membership in S, X not in S, test X for non-membership in S. Is disjoint other, return true if the set has no elements in common with other. Sets are disjoint if and only if their intersection is the empty set. Is subset other, set less than equal to other. Test whether every element in the set is in other. Set less than other. Test whether the set is a proper subset of other, that is set less than equal to other and set not equal to other. Is superset other, set greater than equal to other. Test whether every element in other is in the set greater than other. Test whether the set is a proper superset of other, that is set greater than equal to other and set not equal to other. Union pointer others, set or other or dot dot dot. Return a new set with elements from the set and all others. Intersection pointer others, set and other and. Return a new set within elements common to the set and all others. Difference other, set minus other minus. Return a new set with elements in the set that are not in the others. Symmetric underscore difference other, set X or other. Return a new set with elements in either the set or other but not in both. Copy, return a shallow copy of the set. Note, the non-operator versions of union, intersection, difference, symmetric difference, is subset and is superset methods will accept any iterable as an argument. In contrast, their operator based counterparts require their arguments to be sets. This precludes error-prone constructors like set ABC and CBS in favor of the more readable set ABC dot intersection CBS. Both set and frozen set support set to set comparisons. Two sets are equal if and only if every element of each set is contained in the other. Each is a subset of the other. A set is less than another set if and only if the first set is a proper subset of the second set. Is a subset, but it is not equal. A set is greater than another set if and only if the first set is a proper superset of the second set. Is a superset but is not equal. Instances of set are compared to instances of frozen set based on their members. For example, set ABC is equal to frozen set ABC returns true, so does set ABC in set frozen set ABC. The subset and equality comparisons do not generalize to a total ordering function. For example, any two non-empty disjoint sets are not equal and are not subsets of each other. So all of the following return false: a less than b, a equal b, a greater than b. Since sets only define partial ordering subset relationship, the output of the list dot sort method is undefined for lists of sets. Set elements like dictionary keys must be hashable. Binary operation that mix set instances with frozen set return the type of the first operand. For example, frozen set AB or set BC returns an instance of frozen set. The following table lists operations available for set that do not apply to immutable instances of frozen set. Update pointer others set or is equal to other. Update the set adding elements from all others. Intersection underscore update pointer others set and or others. Update the set keeping only elements found in it and all others. Difference underscore update pointer others set minus is equal to other. Updating the set removing elements found in others. Symmetric minus underscore difference underscore update other set x or other. Update the set keeping only elements found in either set but not in both. Add element to the set. Remove element lm from the set raises key error if lm is not contained in the set. Discard lm. Remove element lm from the set if it is present. Pop. Remove and return an arbitrary element from the set. Raises key error if the set is empty. Clear. Remove all elements from the set. Not not the non-operator version of the update in intersection update, difference update and symmetric difference update methods will accept any iterable as an argument. Not the lm argument to the contains remove discard methods may be a set. To support searching for a equivalent frozen set, a temporary one is created from lm.